Hello everyone, my name is Indra Paul and I am an electronics hardware developer. Here I just want to show one project that is a PC based multiple sensor control, and here I just use one PC, one board, external board, and RS232 cable and PC software, that is the NI lab view, scale and CCS for the remove the error. So I just want to show my project in there. At first I want to show the here, that is my board, that is the one that is one LS2 LCD board, that is a 16 into 2 LCD board. This is a P89V RD2V X2VN, that is a Philips NXP processor that is used. That's RAM is 2K, code memory that is 64K, and RAM is 2K. And that is a one serial port is used, and in my PC that is the connect, this port is connected to the serial to USB converter, that is RS232 to USB converter is used for this, connected to this external hardware with my PC. Here that is the one potential sensor, that is the potentiometer that used, that is the one type of resistive sensor, and I want to show, and that is the one type of resistive sensor. And here I use this is the one type of analog value, and this value is converted to the A to D converter, use the one A to D converter, and this value is stored in my processor, that is the microcontroller, that is P89P RT2PN, and this value is transmit through a DB9 cable, and that is a RS232 cable, and use one RS232 max RS232 chip or IC for control and remove the is any type of incident may be happens. Or another reason, that is the curve reason for control the voltage. And this cable, and have one LCD is used for showing this data for better automation. So at first I should just want to show in there in my PC, that is the code that is my code. So at first that is RS52.H hex compiler is used in here, and I just want to show that I compile, and if I translate this current file, so compiling this RS2 to RS232 with 0 error and 0 warning. This is the very important thing when I just do, but when we are just doing any type of programming, microcontroller programming, then definitely show this 0 error, but 31 or 32 or 6 or 5, more than 1 or more than 10 warning will be generated. But in here I just want to show that here 0 error and with 0 warning. How is it possible? Here I use Code Composer Studio, means follow the rule. Here this 20 rulers generated for the C, for generating C code or writing how to return the C code. So here just want to compile this, that is my CCS compiler, and here I used this project, means this RS232 project, and RS232 project in here, that is my project code. And here just want to debug this program, and that is the debugging is complete. So build is finished. Here just showing this result that build is finished, and here I just follow this code, and again I want to go in there my WPKL software, and follow the follow the style. That's how follow the style or follow the rule. That's how to rating this code in C. So after that I will when I compile this program, then in here the compiling, that is a 0 error and 0 warning is shown. And here that is my program size, that is data 24.0 x data, and total the hex code is generated by this program, that is the 662. Now this project, this code is inbuilt, this built in my processor, that is a microcontroller processor 805 NFP RD2BN, that is P89B RD2BN 51, this processor. And now I just want to connect, I just want to connect I just want to connect connect my PC, my external hardware with my PC. So at first go to accessories, and here the communications and hyper terminal should be occurring there. So just written KK, okay, and COM1, that is your COM1 port, okay, and this baud rate in say here 906 900 9600, data bits 8, parity 1, and stop bits 1, and flow control, that is hardware F live, and now okay. So here have some problem behind occur. I just show this again in here, okay, no, okay. So I have used this NI lab view, and here just use the visas component, and that is the one type of way to connect your PC external hardware with the PC. So right in the one thing, I just have written this program, means how to do it. So this block diagram, so that is my block diagram where just doing this coding from here. And now how to show this program, show returns programs, terminate error, and read this program, okay, read this program. So when I read the program, so here just using one code, that is one tab or control, that is start and stop. So you can, if here I just want to change this value, change the value, then definitely change the value, then here just when the showing the showing this data, that is control data, actually in here 5 volt is used for this resistivity resistive sensor, and 5 volt that equal to 254, that is the 2 to the power 8, that's equal to 256. And here this count the data bit, that is 0 to 255, that means total 256. So here this 8 bit and 256 actually the showing, actually I just want to show that is the actual number is the highest point in there, 255 is the maximum, and when this showing this result in minimum, that is the 0, and all things are 0, okay. So that is the one type of sensor. If here they use the temperature sensor, then we just see the temperature will be deflected by the means temperature will be deflected by the any type of incident. So and there we just show that how to result would become, that is the one type of temperature sensor, that is the one type of pressure sensor, that is the one type of means register sensor. Here we just use to control freely, means any type of environment are not needed for control the system. So here just want to show that how to follow, how to change this follow or the curve, okay. So at first here this termination character is A, that is the all type of rules in the NI level, and what it is 959600, and data bit should be the 8, and here the numerical control is 10. So I just want to move this rule. So here this control, here the data bits are always changes, okay, and this graph, and now up down, up down. So here I just want to control, that is the digital this value, that is this value is analog, okay, this value is analog, means here to 0 to 5 volt is maximum. So where in here just doing so in here just doing this digital value is converted into again analog value, and this graph is showing with respect to time and your amplitude. Amplitude, that means the maximum voltage is 5 volt, 5 volt, and the time, that is the infinity. Okay, so in here just want to convert this value, means convert to value means here just increase the voltage level, then this level is increases, this level is increases, and here just showing means 5 volt that equal to what, 175, but that is just once in short 3.5 volt that equal to 175. If you calculate, that is 5 volt equal to 255, and then you get in the result that 3.5 the equal to how much. And if you get an any type of error, then you control this error by using software. That is the one type of important features or important application of automation. Means hardware, if you if any type of error being generated by your hardware, then you control, means for some time you control this error by your software. Okay, means if your processor being burned or heated up, then not doing any type of thing, otherwise your system will be destructed. So in here 5 volt for equal to, if 5 volt equal to 255, then 3.5 volt equal to how much, then the data will be showing here. And that is the one type of amplitude graph, where that is a waveform graph, that is a waveform chart, and that is a waveform graph. So if I increase this value, then definitely the value is the increases, means the bar graph is will be increases, and at the last time that is the 5 volt, and maximum that is the 5 volt. So after using the 5 volt, after use the 5 volt, then if you setting your graph chart or here the value, then definitely the graph will be up down. But here in this at this moment, here the maximum is 5 volt. Okay, now I decrease this value, then you show the bar graph will be decrement. That means here now the voltage is 4 volt, and the maximum is 205, means zeta response, means a digital response. So this type of project, this type of project maybe use your A to D converter, means you here convert this value and showing this value in here. Means if you want to get an best or means more than precise value, then definitely use your PC. One type of application here, if you use to connect the multiple sensor with your PC, then you please use NI level. That is a very useful software, I think that, and its handling is very easy. So the in here you use NLW, then definitely Visa Insurance or USB and LAN port is available in there. And now here I just use one stop button, means if I stop this graph, then my stop graph. Okay, if I increase or decrease the sensor value, then the graph is not up down. Again I start this button, so that is the input button, and that is the output, then that is the input, that is the increase value, and that is the decrement value. You see this value is up down, up down, up down, up down, up down, up down, and more than up down thing. So that is a very important project. If you want to use, that is in automation sector, obviously we use that type of project in automation sector. Means here I just want to show one automation, means in automation industry, that is the PC based system is very useful for better seeing or better calibration. Means here you just calibrate this value through the PC, means software. you just control or you just control or control this value using software. Means if you want to change the value, then definitely change your software value, then definitely showing their so then definitely you get the result. And ultimately at this finishing time, I just want to speak you that uh, if you want the PWM, if you want digital meter or probe, then definitely use this type of system. If you want to use in biomedical for sensor interfacing with your PC, means here if you are used ECG or EEG, then definitely we can do it using by this soft project. Here just use one ECG sensor and use in your brain, and this brain data may be analog or digital. I think that is the analog data, so use the digital using the A to D converter, and this data through your connected with your PC through a RS-232 or USB cable, any type of communications port, and this cable is added when is added with your NI with your PC, then using this NI library, and here the automation is already made it. So and another application, that is automation. If you want to use in automation, means industrial, means in here multiple, one temperature sensor, one pressure sensor, one humidity sensor situated. And if you want to control, if you want to control your motor or on or off, or control the motor speed using the sensor value, then definitely you just use in there and send the value with your PC, and from here if you create one button send to your external hardware, then definitely you get on the result. And here just use the PWM, one PWM machine, and what the switch control, and switch for control the motor on off or motor speed increasing or decreasing, mean motor speed up down. And after this type of project may be used in semiconductor device, obviously it's automobile industry. So here that is a very important project, and I just want to complete this project through this NLF view. And I just want to show, I want to show this type of project because its data is available in GitHub, and my GitHub account is my username is Indro1234, Indro1234. I just want to show this project because I really needed this type of one job, that is a permanent job. Now I am self-employed looking for permanent job in Europe's subcontinent. Thank you.